We will talk about rejection sampling. So I will use this function f here, and then we will draw the samples for this distribution function. So if you are familiar with the R language, then this one will be the Gaussian, the mixture of Gaussian. So there are two Gaussian components here, and then the mixture is 50-50, right? 50%. So this one, if I don't make any mistakes in this formula, then this one is supposed to be the Gaussian mixture model with balance and component. There are two components, and then the chance to draw samples of any two of them is 50-50. Okay, so in order to do this, I will use the rejection method. So the first thing, I want to generate the x here, variable x, which is if I draw the histogram of x, I will have the numbers between -10 and 10 here. So if I make it bigger for you to see, and then you can see the -10. So they are uniform distribution, the values between the -10 and 10. So I do the same thing with the y. So I will draw the histogram of y here. And if I draw this one, you can see there will be another distribution, but this one is just from 0 to 0 to 0.25, which is a quarter, right? So this is the histogram of y. Now if I combine them all in the same place, and I give in this data frame, then I will give I use this function ff here as the color function. So if it's below so y fx is below y, then I will give label A, otherwise I will give label 3. So if you want to print this table, you can use the grid table function. I just print the head, the top row of the table. I don't have to print everything. So it will look like this. Okay, so you will see the table will have the three components. The first one is the x, the second one is the y. So x will be from -10 to 10, y will be from 0 to 0.5, and then the last component, which is the color will be A and or B. Okay, so now if I draw this one into the the chart, it will look like this. Okay, so it will look like this. So basically you can see those guy B here will be the one below the curve, and then the one here will be above the curve. Okay, so this means that if you just count, if you reject the red dot here, and then you keep the blue dot, and then you will have the sample from this distribution, and then this is what I will show in here as well. So basically I will reject how to reject this one. I will only keep the I will only keep the point in which color equal to B, and then I will give away the rest. Okay, so it take a while. Okay, there you go. So if you do things like this, you will draw the sample. Using the rejection method, you will draw the sample from this distribution. Okay, let me change the parameters of the distribution a little bit. So the first one I want to do is just to make this one not 50-50 anymore. I will makes the minus 1, which is this part, will be 0.3, and then I will make this part to 0.7. So this means that there are 50%, sorry, 30% of the time I will take the sample from -2, and the other one, which is this one, and then the 70% will be taken from this one. So you expect after this, you expect that this one will be smaller or lower, and then this one will be higher. Okay, let us see how it goes. There you go. So you see the 30% here and the 70% here. The second thing is I want to make them I want to split them. I don't want them to share the same thing here, so I will move this one away a little bit, like 3 4, and then this one I move a little bit away, 5. Okay, and then there you go. So they will be move away, and then now you see here, actually I think I get rid of the sum of the sample in here already. You see the truncation part here a little bit. So if I want to solve this problem, I need to change this one to a bigger number, for example 0.5. Okay, let us do 0.5 and see how. You will see more samples on the top, right? Let us see 1, or maybe more than 1. Okay, and then I think nothing much happened because I reject the top already. So let us bring back the two part, the rejection and then the. Okay, so there you go. So if you see here, I draw the sample from all the way from 0 to 1, and then I reject most of the time. I just do nothing. Those guys, the red guys, they have nothing to do with my sampling, because I use the sailing here, the sailing value here, which is very tall, and then it doesn't give me any chance, any other thing. So maybe I would choose something around 0.5 or maybe 0.3, and then it will give me better performance. So basically the accuracy will be the same, but then the performance, meaning that I have to reject a lot because of because of my estimate, the upper bound estimate. So I change this one to 0.3, and then I run this one again. Okay, so you can see here a little bit on top it will be rejected, and then those guys will be rejected all the way, but then the one below, which is B here, they are fine. They are okay, and then you can count this one into your result. Okay, so if you want to uh, if you want to make this one more dense or more sample, you just change the number into 5,000. Maybe you change to 9,000. So in order to change, like to make them to align them, I will give the n here, which is 9,000, maybe 9999. Okay, and then I give n here, and then n here. So basically they will be the same in number of sample, and then this is what we need in order to display this chart. Okay, so now I think I don't need this one anymore. So I just remove this one in from behind and here, and then I just draw the chart again. Okay, there you go. So you have more samples, but then you also reject more sample as well. So basically those guys are useless. Okay, so now if I want to draw the histogram of this thing, I can use the histogram function. So before doing that, I will take them into two parts like this, G1 and G2, in order to compare. Okay, so for G2, I will reject the sample. For G1, I will keep both A and B, but for G2 I will reject the I will only keep the blue part of the chart, and then I draw histogram. So in here I will draw the geom histogram, and then X I will keep like that, and then Y I will remove because I don't for histogram I only need the value of X, and then in here I have to print both of them. So read arrange group, it will be the list of G1 and G2, and then this one I want to compare them side by side. Maybe I will use one in order to make them top and bottom. Okay, there we go. Okay, so I think I need some color in here. I like yellow, and then white, in order to make them, there we go. So you cannot come, to be honest, you cannot compare the two because they are different uh, in scale. Let me try to make this one break small. Actually, it's been not breaks. Okay, there you go. Actually, if I want to compare them line for line, I need this one as 10 as well. So I need this thing, plus x c minus 10 to 10. Okay, so you can see the histogram here, which is around minus 5. This one is around here, which is 4, 5, and this one around 5. Okay, so there you go. I think you can do more than 30, maybe 50, and then yeah, that's it. Not so much. Okay, but then the idea is that just you draw the sample, the uniform sample from this bounding box, and then you reject the one on top, so above the distribution function, and you keep the one below, and then you can have the sample. You can draw the histogram from the sample.